Welcome to the lecture on washing machines, one of the most widely used home appliances in modern households. A washing machine is designed to clean clothes efficiently by combining mechanical action, water, detergent, and electronic control systems. The operation of a washing machine is based on mainly two physical principles: centrifugal force and centripetal force. During the washing process, the drum rotates, creating motion in water and clothes. This movement helps loosen dirt and stains from the fabrics. The wash cycle relies primarily on centrifugal force, which helps distribute water and detergent throughout the load. After washing, the machine enters the rinse and spin stages. During spinning, water is forced out of the clothes due to rapid drum rotation. This significantly reduces drying time and improves overall washing efficiency. Modern washing machines are highly automated and include sensors and microcontroller based systems that optimize water usage, washing time, and energy consumption, making them both effective and environmental friendly. This figure illustrates the various inputs and outputs involved in an electronic washing machine. The input section consists of components that provide information to the control system. These include water level sensors, temperature sensors, door switches, and program selection buttons. These devices continuously monitor health of the machine conditions and user conditions. The central controller, usually a microcontroller, processes these inputs and determines the appropriate action. The output section includes actuators such as the drum motor, inlet valves, drain pumps, heaters, display indicators, and alarm systems. Based on the received input signals, the controller activates these outputs at the correct time during the washing cycle. For example, when the water level reaches the desired value, the controller stops the water inlet valve. Similarly, when the selected washing period is completed, the controller shifts to the next stage automatically. This interaction between sensors, controllers, and actuators enables the fully automated operation and ensures efficient washing performance. Washing machines can be classified into three major categories. The first type is washer. These are simple single tub machines that perform only the washing function. Drying or spinning may need to be done separately. The second type is the semi-automatic machine. In these machines, some operations are automatic while others require user intervention. Typically, the user transfers clothes from wash tub to spin tub manually. These machines are economical and consumes less water. The third type is the fully automatic washing machine. These machines perform the entire process automatically, including washing, rinsing, and spinning. The user simply loads the cloths, adds the detergent, selects a washing program, and starts the machine. Fully automatic machine provides greater convenience, better washing quality, and advanced features such as fuzzy logic control, load sensing, smart connectivity. This slide shows different models of washing machine commonly available in the market. Generally, washing machines are categorized as top loading and front loading models. In a top loading machine, cloths are loaded from the top. These machines are usually easier to operate and often have shorter wash cycles. In front loading machines, the cloths are loaded through a front door. These machines are known as higher washing efficient machines, reduced water consumption machines, and gentler treatment of cloth machines. Modern washing machines are equipped with advanced electronics, digital displays, programmable controls, and intelligent sensors. Some smart washing machines can even be monitored and controlled remotely through mobile specific applications. The increasing use of electronics and automation has transformed washing machines into intelligent home appliances capable of delivering excellent performance with minimal human effort. Let us now understand the major components of a washing machine. The temperature sensor measures the temperature of the washing water and provides feedback to the controller. A safety cutout switch protects the machine against abnormal operating conditions. The keyboard or control panel allows the user to select different washing programs and settings. The water level gauge monitors the amount of water inside the drum. The washing drum motor provides the rotational motion necessary for washing and spinning. Power switches control the operation of the motor, heater and other electrical components. The heater raises the water temperature when warm or hot washing is required. The water inlet valve controls the entry of the water into the machine. The suction pump removes wastewater after washing and rinsing. Finally, the control lamps indicates and provide information about the machine's current status and operating cycle. All these components work together under the supervision of the electronic control system and ensure smooth and efficient operation. The agitator is one of the most important parts of the washing machine. It is located inside the washing tub and is responsible for creating movement in the water during the washing process. The agitator rotates continuously, generating strong currents that circulate water and detergent around the clothes. This motion causes the clothes to move and rub against one another and interact with the detergent solution. As a result, dirt and stains are loosened and removed from the fabric surfaces. In some washing machine designs, instead of a central agitator, a rotating disc or impeller is used. These systems create powerful water currents while providing gentler treatment for delicate fabrics. The design of the agitator directly influences washing performance, water efficiency, and fabric care. Therefore, manufacturers continuously improve agitator designs to achieve better cleaning results while minimizing the wear and tear on the clothing. So in this lecture, we explored the working principle of washing machines, their input and output systems, different washing machine types, major components, and the role of agitator in the cleaning process. So in the next lecture, we will discuss microwave ovens, dishwashers, their construction of microwave ovens, construction of dishwashers, components associated with microwave ovens, components associated with dishwashers, and working mechanisms related to microwave ovens and dishwashers. So I hope this lecture is useful. Thank you for watching this lecture.